In this question, we're told a right circular cone lies inside a sphere of radius 1 meter as shown. The center of the sphere, O, lies x meters from the base of the cone. Then we're given the volume of a cone, and the first thing we need to do is write R in terms of x and then h in terms of x. Now, the way the diagram is drawn here is a bit confusing. So I'm actually going to draw this out differently. Okay, so if you imagine here, so we have a sphere, and then the base of it then is what's given in this question. And there is our cone. So then we have our center O, and then we have this right angle triangle in the middle of it, with x, 1, and then our radius R. Then we have h, which is the height then of our cone. So the first part, when we have to write R in terms of x, that's easy enough because that's just going to be a Pythagoras question. So the center here, the right angle there, so we're going to have x squared plus r squared is equal to 1 squared. So then r squared is equal to 1 squared minus x squared. So r then is equal to the square root of 1 minus x squared. Now the next bit looks a bit more difficult, and that's why I drew it out again. So we need to write h in terms of x. So remember, we have our center point here, and from our center to the top of the sphere will be a radius, and we already know our radius is 1. So looking at this now, we can see that h is equal to a radius 1 plus x, which is the height of that right angle triangle in the middle of our sphere. So that means that h is equal now to 1 plus x. Okay, the next bit now, we need to show that v, our volume, is equal to pi over 3 times 1 plus x minus x squared minus x cubed. Okay, so to start with this, I'm just going to write out what my volume formula is. That is a third times pi times radius squared times h. Now I've already written my radius as square root of 1 minus x squared, so that can go in. And h then is 1 plus x. Okay, so let's multiply all this out now. Okay, so I'm going to have pi over 3. Now this will just become 1 minus x squared, because the squared and the square root will cancel out. Then I have 1 plus x. Now expanding our brackets, we'll have 1 times 1 is 1, 1 times x is just x, minus x squared times 1 will be minus x squared, then minus x squared times x will be minus x cubed. Then all this is being multiplied by pi over 3, and there we have it. That's exactly what we wanted to get. Okay, so that's our volume now. Now, that was part B. For part C then, we're asked to state a suitable domain for the function. So remember, a domain is your input. So the input of values that x could be. So remember, the radius of the sphere is 1. So x cannot be greater than the radius. Likewise, x cannot be 0, because we're told that x is a value. So then, if x has to be between 0 and 1, the domain is simply going to be greater than 0, less than 1. And that then is our domain. Okay, for the next bit then, we need to find dv dx. So we have v is equal to pi over 3, then 1 plus x minus x squared minus x cubed. So dv dx, so I'm just going to leave the pi over 3 there. 1 will be gone, so the x will become 1, minus x squared will be minus 2x, and minus x cubed will be minus 3x squared. Okay, so that's dv dx. The next bit now, I need to find out what x is. And to do that, we'll equal this to 0. So now I can see there's a pi over 3 at the front, so I'm going to actually divide across by pi over 3 to get rid of that. So now I'm left with 1 minus 2x minus 3x squared equal to 0. So I'm going to bring everything here over to the right, or else divide across here by minus 1 to make it 3x squared plus 2x minus 1 equal to 0. Okay, it just makes it a lot easier now to factorize this. So I'll just write in what I did there. So I just multiplied across by minus 1, or else I could have just brought everything to the right hand side. Okay, so let's factorize this. So I'm going to have 3x here. So 3 is a prime number, so it's going to have to be 3x and x. Then for my constant 1, it's going to have a 1 and a 1. Now the signs is important. I'm going to have a plus here and a minus here, because 3x times 1 would be 3x, minus 1 times x will be minus 1x, and 3x minus 1x will be plus 2x. Also then, if you expanded minus 1 times 1, I'd have minus 1. Okay, so then let me just write that in, 3x and minus x. Okay, so now I'm going to have 3x minus 1 equal to 0. So I have x is equal to a third. The other side then, x plus 1 equals 0. So x is equal to minus 1. Now, seeing as x had a value in our diagram, can't be a negative value, so can't be minus 1. So that means x has to be a third. So now let's find out what our maximum volume is. So let's put a third back in to our volume. Okay, so I'm going to have a pi over 3 times in 1 plus a third minus a third squared minus a third cubed. Okay, and in the question they haven't told us to write it to any decimal place, so they've given us no guidance on rounding. So I'm actually going to leave this in terms of pi. Okay, so when I put all of this here into the calculator, that gets me 32 over 27. Now, multiplying this now by pi over 3, that will get me 32 pi all over 81. So this is my maximum volume. Now, if we wanted to check as well that it was a maximum, so let's just go back and see what we had for our dv dx. So our dv dx was pi over 3 was 1 minus 2x minus 3x squared. So let's differentiate this again. So now we have minus 2 minus 6x. So let's put a third into this. So pi over 3 minus 2 minus 6 times a third. Okay, so that's going to be pi over 3 times minus 4. So I have minus 4 pi over 3, which is a negative value, so therefore it has to be a maximum. Okay, so that is that question finished now. Okay.